Hi, in a previous mailbag video we took a quick look inside this XuanZu X2U808 valve-based hi-fi amplifier you can get on eBay for like $50 or something like that. It's one of these things, uses two JFETs with pilot lights here, and you can see the little pilot lights in there. Look at them. And of course, yes, it's got the obligatory wanky blue LEDs in there to make them look all fancy-pantsy. Now, a few people asked, do the valves actually do anything in this thing? Are they actually hooked up at all, or are they just, just there for show and it's just an absolute joke? Because they've just got a couple of regular audio grade op amps inside this thing, as we saw last time. But clearly the heaters are on. Look, the pilots are on. There we go. We can see them actually heating up there, so it's obviously doing something. And there was another video someone linked in and posted, somebody else did a tear down of this thing, and they were actually connected, but how are they connected? How is it actually in the signal path? Because valves are usually high voltage operating devices, and it comes with a 6-volt plug pack, 6-volt DC plug pack here in the back, and we saw maybe some boost converter circuitry in there and stuff like that. But anyway, I thought we'd do a little reverse engineering of this thing, of the circuit in here, and just see what it actually looks like. Let's go. Now, as we saw last time, these are 6J9 valves, and it just so happens we do have the datasheet for these. These are from Sylvania, so we can get the pinouts for this puppy and trace out the circuit. I'll link in the datasheet down below. And if we have a look at the actual board here, you can see two audio grade op amps, classic NE 5532s, nothing wrong there at all. And we've got ourselves our valve sockets, and as we noted last time, it looks like we have a couple of switch mode controllers here, little tiny 5-pin SOT23 there. You can tell it's a switch mode converter because we've got ourselves a diode, we've got an inductor, and we've got some output capacitance here, and a controlling element here. So clearly a switching converter. We've got another one down here as well. So we've got two switching converters, and what they're actually doing, what voltages they're generating, what for, etc. we won't know until we actually take a look at the circuit. And look, I mean, the valves are clearly connected in here in some way, shape or form. At least, a good lot of the pins are. I'm not sure if every pin's actually connected, but yeah, there's not a lot of complexity in that circuit at all, so we shouldn't have too many problems actually reverse engineering that. One of the issues with reverse engineering, I've done a video on this, on how to reverse engineer. In that case, it was the Rigol DS1054 analog oscilloscope front end. So I'll link that one in if you haven't seen that. So I won't go into detailed explanations of how to reverse engineer this. Suffice it to say that it's much easier when you have a double-sided board like this, and through hole parts, fairly easy to trace everything, so shouldn't take me too long. Well, I thought I had the data sheet, and here it is. It's the 6J9 from Sylvania, and this has 6J9 written on it, and it's a triple triode. Okay, fantastic. Basically, essentially 3 JFETs with pilot lights in the one package, but it's in a 10-pin bulb, and that didn't register until I went to look at the pin out here. I labelled things, there's the cathodes, the gates, the plates, the heaters, everything's fine, but this one is only 9 pins. There is no 10th pin for the cathode. So I'm not sure if it's the same thing, but without the cathodes, making 2 of them essentially useless, 2 of the triodes useless, or what? And no idea. What the? And as it turns out, I look inside this thing, and this pin here, you can see, is not actually connected to anything at all. So, yeah, what the? Nothing matches up. Trap for young players. Even though this is a 6J9, it's actually got 6J9 space, J, sort of like hanging on the end of it. And this is apparently a replacement. And if you look at the eBay ad, they actually say that valve is actually a replacement for No, it's not actually a genuine 6J9 from Sylvania, which we had the datasheet for, which didn't actually make any sense because it's a triple triode, you know, designed for RF amps and VHF stuff. You know, it didn't, too complicated, too high frequency, didn't seem to make sense. But it's actually a substitute for the E180F, which they also mention in the ad as well, in the eBay ad. So you look up the data sheet for that, and sure enough, it's a pentode designed as a wideband amplification, and this is pretty much what you'd expect in something like this. A pentode is quite common in these types of now vintage tube audio amps, and we've actually got some better data. We've actually got some graphs, characteristic graphs and stuff, so beauty. Now let's take a quick look at the pentode if you haven't seen it before, if you don't know your valve stuff. It's one of the more complex valves due to the many various elements in here. It's more complicated than a triode. For example, you might have heard of that. Well, this is a pentode. Why pentode? Well, because it's got 5 different elements. 1, 2, 3, 4, 5. There you go. So let's take a look at them. Up the top here is the plate, which is also called the anode. And then we've got a couple of grids in here. We've actually got 3 grids. The next grid down is what's called the suppressor grid, and then the one below, one in the middle there, is the screen grid, and the one at the bottom here is the control grid, otherwise known as the gate. So compared to a JFET, which is essentially what valves really are, they're JFETs with pilot lights. The pilot light being the heater down here, of course, so you hook up typically a 6-volt heater here, and that just heats up the cathode, which emits all the electrons, and they flow through the various grids, if they're allowed to, based on the grid voltages, to the plate up here to the anode. And yes, this is electron current flow as opposed to conventional current flow, which you're probably more familiar with circuit design. But essentially, what it comes down to is just like a JFET, this is basically our gate, our input here, and then we've got our cathode and our anode here. And if we take a look at a little DaveCAD drawing of a rudimentary pentode amplifier, then basically what we've got is the gate here that you saw before. The gate here is essentially, that's the control grid down here, so that's basically the input or the gate of the JFET, so to speak. And then we've got our cathode resistor down here, which sets the bias and things like that. We've got some bypassing on there, and then typically the suppressor grid is going to be strapped down to the cathode down here, and then your screen grid here is typically connected up to your positive voltage rail here, which we'll call the HT rail, the high tension rail, or you can call it whatever's more traditionally used with valve amps and things like that. Anyway, that's just got some bypassing on that. Won't go into details of why all that sort of jazz is done. But then we've got our anode resistor up here, which then just AC coupled off to give our output. It doesn't have to be AC coupled, but it likely is in a typical circuit. So that's basically, hence why valves are effectively JFETs. They're transistors. They're, it's just that they use old school. They're filled with vacuums and they use a little heater element, but essentially they're transistors, or more specifically, of course, field effect transistors, because there's electric fields in here. Get it? That's what JFET stands for, junction field effect transistor. Same thing, JFET with a pilot light. Now, without having actually started on the reverse engineering of this board, i.e. tracing out every single trace and seeing where everything's hooked up, maybe we can just have a quick look of where the pentode is actually in this thing. Is it used as the input preamp? Because we've basically got our input here, stereo, of course, hence we've got 2 op amps and 2 pentodes up here. There's going to be 1 for each channel. So, here's our input and here's our headphone output. So, is the pentode used as the headphone output driver, power amplifier for the headphone, or is it used as the preamp input? Well, my guess is it's typically used as a preamp input, so that's what I think we'll find here. And if you check it out, you'll notice that our input here There's a trace going off. It goes over to our pot here. Okay, so it looks like our pot is like directly on our input. That's our volume control pot. So it's effectively attenuating the input here. And then, if you have a look here on the bottom, that goes over here to these two caps. So they're AC coupling that. And bingo, these go over to the pentode here. So it's obviously used as an input preamplifier. And of course, the first thing you want to do this is avoid Murphy and make sure you get the pinouts right. This is actually the bottom view, and the way I was able to figure that out, if you don't know like the internal structure and stuff like that physically, see it, look, they've got a not connected pin here, and it was fairly obvious to see which pin was not connected. So that's actually pin 1. It's a bottom view, and when you flip that over, there we go. That becomes pin 1, that becomes pin 1. Make sure you mark them and you don't come a gutser. And sometimes it's just easier to desolder things to look under them. Like you remove the chips here, you might be able to see some traces going under there. That's very handy. Just otherwise, you start to randomly, buzzing out pins. And you can see, trace from there to there, which you wouldn't have seen necessarily unless you took that out and you didn't know there was a resistor under there, for example, hidden under the socket. So it's well worth taking out. And there's the blue LED, of course, the wanky blue light. Ooh. And it goes without saying, you only have to do it for one channel. Once you've traced out one channel here, the other channel is going to be identical, so just don't bother. And during the process, you end up with some sort of gibberish like this, which you have to redraw because it doesn't really make much sense. So after a little bit of doodling, you end up with this. Here it is. Here's the Dave CAD reverse engineering edition of this hi-fi headphone amplifier. Now you'll notice here that the screen grid is actually connected up to the plate up the top here. And what this does is it actually converts it from a pentode into a triode. So it's effectively working, you might as well have put a triode in there. Now, the pros and cons between a pentode and a triode in terms of a front-end preamplifier like this. But I believe that connecting it as a triode at least offers lower noise, but there's a whole bunch of other downsides as well, which I won't necessarily go into. One of the disadvantages of that apparently is that you're going to need a higher drive plate drive voltage up here. So yeah, But doing this also apparently gives it the triode sound, in quote marks. Oh, God, let's not go there. Anyway, they quote this thing. The spec is like 0.005% distortion, okay, in the passband. And, vowels are supposed to do funky things sonically when you overdrive them and stuff like that. But who the hell's going to overdrive a headphone preamp front end like this? It's just, I don't know, it just seems like a complete wank. Anyway, what else we've got here? The plus 6 volts power directly from the plug pack. It's going straight to the heater. And by the way, of course, we've only got one channel here. There's going to be an identical channel because it's stereo for the other channel. So only need to draw one here. And then there's two DC. Oh, anyway, so this, the filament heater voltage here, not surprising because it's a, valves are 6 volt heater voltages. That's why they use a 6 volt plug pack. Didn't need any extra parts for that. No worries whatsoever. Those two DC to DC converter switch modes that we saw in here, not that little 5-pin SOT23 and the SO8 there. One generates the negative voltage, which I think was this one down here. We've got 3 output caps, 100 mic, 16 volts, so there they are, 3 there. We've got 3 for the positive 12 volts, so this is a this is the plus 12 volts switch mode, and these two will be the input filter caps for those, which I didn't draw. And sure enough, they do have the suppressor grid connected down to the cathode down here, which is, fine and dandy, as we saw in the original Dave CAD one over here. But you'll notice that it is different. They've got it on the high side here, and they've taken the output signal from the cathode instead of from the plate. So if you compare that with a FET circuit or even a BJT circuit, what happens if you tap off what is effectively the source or the emitter here on a regular transistor circuit, which you might be more familiar with? Well, It's an emitter follower, a source follower, or in this case, a cathode follower. So basically this thing is not a preamp as such, it's just a buffer. It just takes our high impedance input here and just buffers it, and that's it. And this did confuse me for a second, because I was kind of, I don't know, I had it in my head that there would be a preamp in here, but oh, you know, of course, because this is a line input. It's not like it's a microphone input and it needs a microphone preamp. It's designed to take line level signals and give you your headphone out. So you don't really need, well, you don't need a preamp on the preamplifier. You just need a buffer. That's pretty much it. In fact, they probably could have got away with the buffer and gone straight into the op amps. As I said, wank factor, you know, tubes look cool, they light up, what's not to like? And it's not even a complicated, you know, biased arrangement for a cathode follower, for a tube cathode follower. You can get, you know, much more complicated ones. So it's as simplistic as you can possibly get. It's almost as if, you know, yes, they have just thrown the tube in there for the sake of having a tube. And with the fairly generic tube they've got here, and the simplicity of the circuitry, the fact that they're using it as a buffer, it's like why? It's just complete wank factor. That's all it is. It's got to be. But anyway, after that, what they're doing, the NE5532, the AC coupling that, and then we're basically, this looks a bit convoluted. You might not have seen this before, but, you know, let's just take the DC condition first, okay? When you're trying to analyze circuits, taking the DC condition to figure out what's going on, it's not a bad way to do it. So C12, a capacitor is going to be open circuit, okay? So pretend they're not there, right? What have you got? Well, also pretend that this op amp is not here, okay? Because it's just a voltage follower, okay? So it's effectively doing nothing, okay? So you can take all that out of the circuit and just connect that through to there. What do you got? You've got a 10k resistor. Don't worry about this capacitor here. It does nothing at DC. It's open. So you've got a unity gain amplifier there. The reason that they've put in the second op amp here is for extra drive capability. So it's the same signal, exactly the same signal, but they're now buffering that with a second op amp, and then driving the output of this op amp is driving through this 47 ohm resistor to the output, and this one's driving through the 47 ohm resistor. They got the effectively parallel drive there from the two op amps. Not necessarily uncommon. But in the AC condition, of course, then these capacitors are going to matter. I didn't measure the values of this, so I don't know the necessarily roll-offs. But of course, you will start then getting some gain at AC, because this R12 down here is a very low value, 4 ohm 7. It's effectively, basically just shorts this out to ground. So, you know, depending on the frequency here, you're going to start getting a bit of gain in this thing. So how flat the passband gain is in here, you know, presumably over the audio bandwidth, I don't know. You'd have to get the exact values and measure the performance of it. Now, I actually posted a photo of this while I got the wrong data sheet. I posted it on Twitter, and some people said that apparently this 6J, 9J or /E150F valve is, you know, just a pretty crap quality valve. It's just, you know, generic because it's popular, because, well, there's lots of stock of it or whatever. And, well, yeah, I don't know either way, but yeah, and then they haven't hooked it up as a pentode. They've hooked it up as a triode. So yeah, go figure. The performance of this thing's probably meh. Now, just to prove that this is indeed a cathode follower, so the output is going to be the same as the input, or actually not quite. It's the output here is always going to be slightly less. The gain is always going to be slightly less than one. That has to do with various parameters in the pentode itself. And it has to do with all sorts of stuff to do with valve amps, and I certainly won't go into it, but, you know, the amplification factor mu comes into it, and the output impedance, and, you know, everything else. And interestingly, they give you the characteristics when it's wired as a triode, exactly as we've got here. Look, the G2 is connected to the anode, exactly what we have here. So it's not, this data sheet's really nice. They give you those values for this particular configuration, because it is going to change, as opposed to here are the characteristics for just as it's used as a pentode. And the other thing here, I mean, as we said right back at the start, the nominal operating voltage of valves is quite, very high. It's like hundreds of volts. And in this case, what this one means is it's its nominal anode supply operating voltage, and 160 volts. Well, we've only got a plus minus 12 volt rail here, so that really changes the characteristics of this thing, but it may not hugely matter in this sort of low signal level application. Although I think they are doing the right thing here, although I'm no expert on valve amps, that's to be certain. But the cathode resistor here is usually, a rule of thumb, should be an order of magnitude lower than the load impedance, which we've got here at, AC coupled 47K. So, they're at least got the right order resistor value for the cathode resistor. Although that's probably as high as you'd want to go, ideally, probably the lower the better. So let's actually power this thing up, and I won't measure the performance of it, so don't get all excited. No, it's got 0.008% distortion instead of 0.005. No, not going to happen. But I'm just basically feeding in a signal from my function gen over here. I've just got half a volt peak to peak, 1 kilohertz sine wave, nothing fancy. So let's switch this puppy on and see what happens. The yellow trace is the input, so that's the control grid input. So right down here, I'm measuring the control grid input. That's the yellow waveform, and then we're measuring the cathode on channel 2. So that'll be the blue signal here. So let me switch this thing on and see what we get. And we expect a gain close to 1. No phase issues or anything like that, no inversion. It's a cathode follower, but we do expect the gain to be slightly less than 1. So it takes a while. It's heating up. Takes a while for the heater. Come on, you can do it. Here we go. Whoa, whee, and boom. There we go. Look at that. It's pretty close. And if we go to channel 2, oops, I switched off channel 2. If we go to channel 2, that's the problem with having, the single control handling all 4 channels. You never, you got to check which channel you're on before you hit the button. You can accidentally turn it off like that. It really is quite annoying. So yeah, I did it again. See, so you got to make sure channel 2 is selected, and then we can center that, and bam. Anyway, that's just a little side rant. So there we go. We're looking at, again, slightly less than 1. There we go. Just a smidgen under, but, that's pretty good. That's pretty good. That's following pretty well, as you'd expect for a cathode follower. And you'll notice if I actually switch this off, okay, and then I, switch it back on after, a few seconds, a few tens of seconds, then it's going to pretty much come back straight away because that cathode is still hot. Literally hot. So it's, so it doesn't need that 10 seconds or so to warm up, but you'll find that the data sheet will actually tell you the warm-up time. And sure enough, Bob's your uncle. Check it out. Cathode heating time, nominally 12 seconds, maximum 18 seconds. And curiously, you'll note they've actually specified a distortion here, which is interesting. But once again, I'm not hugely familiar with valve data sheets, so I'm not sure what particular configuration that actually refers to. But yeah, 1.6% for a 1K load for 100 millivolts RMS input. December 1968. Jeez, we hadn't even landed on the moon then. So that's probably all this little One Hung Low brand hi-fi amp actually deserves, I think. But anyway, I think that was rather interesting to have a look at that thing. And yes, the tubes do actually do something. There you go. They're cathode followers. So I hope you learnt a little bit about tubes there if you haven't seen them before. And no doubt all of the tube aficionados will come out of the woodwork and rave on, and all the audio fools will come out and they'll start raving on, and they'll have a big flame war, and it'll be hilarious. Love it. So there you go. I think this has gone for long enough. I've got 30 minutes worth of material. Oh, goodness. Got to go edit this thing before I head off on holidays. Woohoo! In fact, when I'm posting this, I'm probably on a beach somewhere. Yes. Anyway, if you liked the video, please give it a big thumbs up. And if you want to discuss it, jump on over to the EEVblog forum, YouTube comments, all that sort of jazz, Anyway, catch you next time. wait, hold on to your hat. I thought I would actually get a second opinion on this thing, and what better second opinion than one of the world's best audio designers, my mate Doug Ford from Doug Ford Analog Design, who you've no doubt seen on the blog before, and a former head designer at Rode Microphones, former head designer at Jan's Audio, a couple of companies you might be familiar with. And yes, he's designed amplifiers, mic preamps, including tube preamps as well. So he's one of the best in the world. What's his opinion? Well, I asked him quickly, and he said basically, I'm happy to say, he came to pretty much the same conclusion I did, in that it's basically a wank. Really, there's no point having the tube in there. Yeah, it's gonna, Doug says it's most likely add some second and third harmonic distortion into there, but ultimately it would perform better, and it'll be cheaper and simpler if they just use the NE5532 op amp. So yeah, what a wank. Thanks, Dougie. And if you haven't seen Doug's microphone, multi-part microphone design video series, I'll link that in down below. It's fantastic. It's like 5 parts or something. We sat down for hours at the whiteboard. It's not just about microphone design. It's all sorts of design techniques and circuit topologies and all sorts of weird and wonderful things. So definitely check that out. Catch you next time.